Hey, I said a lot of things. None of them were heard. Okay. So, okay. Let me say them again. We're going to have an exam on Wednesday. We're going to go over a little bit about what the exam is going to be on. We're going to talk a little bit about file writes, because I don't think I've ever actually explicitly covered file writing in this class yet. We've done a bunch of file reads, but never file write. We'll talk about default parameters, which won't take long. And then we're going to spend the rest of the day doing testing and debugging, basically talking about the project, talking about what I intend for people to do for the test script, talking about what the debugging problems on the exam are going to be like, that kind of thing. Okay, and so because the exam is going to be released on Wednesday, we won't necessarily have a class on Wednesday, so you guys are free on Wednesday. Okay. For those of you who caught the intro music, it sounded a lot like a Liszt, but it's actually Brahms. Sometimes, even though I knew who it was, I would have sworn. Anyway, let's get on with it. So, what do we want to talk about first? First, let's talk about file writing. So let's make an example. Okay. So, just to remind everybody, basically to open a file, you want to do one of these two things. Let's say def so open my file. Let's put in a file name. And so what you can do, one way to do it is to say open file name, and you can put the read permission in, or you don't have to, right? So it's not required. And then what you can do is you can assign this to some kind of file object. So this is my read file. Is this, and then you can do something like read file dot read lines print read file dot read lines, and you can run it like this. Let's say debug practice.py. So if we just run this, we see that the file is just printed out. And that's fine. So, okay. And if we open the file this way, there's one thing that we have to remember to do, which is we have to do readfile.close at the end. So let's do it a different way. The same thing. So def open my file with, and then we'll have a file name. So these lines of code are equivalent to this, where you say with So what this is doing is with is basically creating a little bit of scope here. So what it's doing is it's running this function, opening file name, and it's sticking whatever comes out of this open file name, which is actually a file object. It's sticking it into read file. So the point here is that basically that does the same thing. We can actually just copy paste. There we go. And here we actually don't need to close. And the reason is because this with statement has a secret, basically exit function that runs. And when it runs on a file, it'll close it. So that's something that you don't necessarily, it's not obvious from the start, but it does happen. So if you have a read file equals open file with the read tag, it'll do that. Technically, most of the time, you don't really need to close files opened only with read. I mean, if we're being really precise, yes, you do. But what I'm saying about it is that if your program terminates and say a read file, a file with read permissions doesn't get closed, normally that doesn't cause any problems. But what we're about to discuss is something that actually does cause problems if you don't do it right. So let's say write favorite things to file, and so we'll have a file name. And so let's do the same thing, except we're going to do with open file name. Now here are the other two tags that you can add in here. Instead of R for read, you can put W for write. So this is opening the file with write mode. Now, so the difficulty here is that when you open a file with write mode, it blanks the file out. So make sure that whatever you're doing, if you're opening a file with write mode, where is the, there it is. If you do this, you'd better not about what was in the file, if it existed, because it will delete it, erase the file, or zero it out, whatever you want to say. So the thing to keep in mind here is that this write file will zero the file, create it, or alternatively, if the file doesn't exist, it will create one. In fact, yes. So let's do that. So let's comment out that, and let's say write favorite things to file, and the file is going to be called, we have to make sure it's not called anything that's in this like exam practice or exam, I guess I'm in the exam questions directory. So let's make it test.txt. And so, or whatever. And so what we have to do here, let's input something, and then we'll do write file. Oops. Let's not make it a recursive function. So basically there's two write commands that you need to know. The first one is write, and the next one is write lines. So let's run this thing and see what happens. So the first thing that happens is that it asks for something. And so as it's asking for something, we're going to type in something. Okay. Let's open up this test.txt. There it is. So we see that something's been written to the file. Is there a limit on how big the file will or can be? The answer is no, not really. You can write gigabytes to files. It won't stop you. The only difficulty is obviously once you start getting close to the gigabyte range, you have to be careful, because if you write a file that's, 4 gigabytes, that's movie size. If you write it 40 gigabytes, that's Blu-ray size. And if you write it 400 gigabytes, that might exceed the size of a hard drive. So you have to be very careful about not letting files get too large or too out of control. But nothing in this class will come anywhere close to that. If you write any more than a few kilobytes to a file in this class, then it's too much. So let's just say there we go. Let's make this a little bit there. Okay. Well, so if you allocate too much memory in Python, it'll crash. So for instance, if Python is running in 32-bit mode, then it can't actually access more than 4 gigabytes of RAM at the same time. And even that's a bit of an upper limit. But if you're just writing things to a file and you don't have them stored, if you're just kind of reading and writing, then it will eventually just probably fill up the hard drive or reach the boundaries of the file system if file system can't support larger than certain size files, etc. Like FAT32 can't support certain sized files. So I want to show you something that has to do with, whoops, Python was telling me I'd forgotten that, and I did. So, all right, let's type in something. Something is going to be robots. Something else is going to be happy days. Something else is going to be red team, blue team. Basically, the explanation of with and as is that this function gets run, and whatever the result of this function is, basically what I mean is whatever gets returned from this function is set into this variable. It's really the same thing as doing write file is equal to open file name. But you'll see this a little bit more commonly in Python with files and certain other things. It's also a way to say that it's kind of also a little bit of scope, because it basically creates like a little kind of local variable that exists within this with statement. Like write file won't necessarily be guaranteed to exist properly outside of the with statement. In fact, as I was saying, with is going to close the file as we leave. So when with closes the file, then even if the write file variable still exists, it won't work correctly. Yeah, the way to think about it is pretend that this is its own little mini function. It's not really a function, but it's its own little blob of scope. It's like a for loop, like the index in a for loop, or some thing that only exists inside of a while loop or something like that. That's the way to kind of think about it. Okay, so let's do, what else do we want to do? We want to say cell phone, telephone, and that's it. Okay, so now I'm going to type quit, right? And I think quit is the thing that quits us, yes. So hopefully I haven't screwed this up. Good, it's terminated. Okay, now let's go and check what's happened. Hey, wait, what's happened? Well, basically everything got smushed onto one line, right? So this is one thing to keep in mind about the file write. This, unlike print statements, you know how print has like end equals next line secretly? Write does not. So you need to manually put in the next line. So yeah, the standard thing is to do something like this, if this is what you mean. Now technically, if all you want to do is write a single line, and like if this is what you wanted, then you're fine. But clearly most of the time when you write something, it's not exactly what you want. So you know, blah, gra, da, do, Homer Simpson. Homer Odyssey. That's a word that I always had a trouble spelling. And quit. So we see here that all the words have been written on separate lines, so that's good. Okay, so let's copy paste this function. And so I'm going to call this one write lines, favorite things to file. And so we're going to do everything almost the same. except in this case what we're going to do is we're going to create a list. So write list is equal to new list. And then every time we go through here, what we're going to do is instead of writing everything, we are going to do write list, append the in string, and then finally what we're going to do is after we're outside of this while loop, but before we leave, we're just going to say write file dot write lines, and then we're going to hit it with the write list. So let's check it out. What happens? So Python is a fun language. It works. So what happens? Let's take some bets. Is it going to add the new lines, or is it not going to add the new lines, right? So theoretically you'd say, oh, this should add the new lines, and it doesn't. And so you see here, I should flip it and stay here for a second. You see that it didn't add any of the next lines. You would think that a function called writeLines would take a list of strings and put them on separate lines, right? Because the function is called writeLines. But actually what it is it's really writeList with nothing in between. So what you want to do is up here add the new lines to your strings. This is just you would think that a function, normally Python won't do this to you, but in this one case Python has named a function a thing, and that thing is kind of deceptive because it doesn't really do what it says it's going to do. It almost does it. It just doesn't put in the new lines for you. And the only thing to say is that generally I think that at this point you guys know that every time we do a file read or a file write, when you do the file reads, it doesn't prune off the end lines, and when you do a write, it doesn't put them in. So, you know, that's just a standard thing that this thing does. But notice that every time we open this file, it will actually delete the whole file. So, when we open it, let's see what happens. When we run this, so now it's asking for something, so we're sitting at this line. So we've already opened this file, which means the file is now blank. So let's see. So what should we type in here? I think that's fine. Quit. So now let's see what happens. There we go. So basically, you see that if you add in the new lines into the string itself when you append into the list of things that you're going to write, then that's acceptable. I would say generally you're not going to be doing a lot of write lines. I mean, maybe actually you could do it in the project. Yeah, you can do it in the project. Okay. So what if you don't want to delete the file? What if you just want to open it for reading and also writing? So let's do that. There's a different mode that you can use. And I'm going to spoil the surprise. It's called append mode. And so we're going to copy paste all the same stuff from this function. Everything's going to be the same, except I'm actually just going to start deleting these comments because there's too much here. The reason why I'm leaving all of these comments and the reason why I'm leaving all these near duplicate functions is so that when I upload this to the GitHub, you can look at these as examples and they're not all just gone. In fact, you're right, append will add to the end of the file. So what it does is it opens the file and it sets like a little secret cursor, what's called a file pointer. You want to know where the GitHub is? I can send you that. That's no problem. Oh. Cool. So what am I doing? Right, appending. So the point is that in order to append, what we're going to do, not terribly surprisingly, we're going to change this to A. So now this is append mode. And so we can just do this, and let's see what happens when we do append favorite things to file. So, you know, it's sad because if we had a little bit less latency, I'd ask you for all your favorite things. You know, of course now I'm forgetting because it's like that song, you know, from that movie, Roses, something. Packages tied up with string, right? What other things are our favorite things? Farscape. It's a great show. Battlestar. Yeah. VG. The near and coming apocalypse. You know. Oh yeah, JP. They only made one of those, right? They didn't remake it for the big dollars in the last decade, did they? No, certainly not. Okay. Yeah, heat death of the universe. T going to infinity. Okay, quit. Oh yeah, you're right. Bright copper kettles and warm woolen mittens. As it turns out, somebody pulled an all-nighter getting your project ready. So somebody has the recall of like a turnip. All right, let's check out this file and see what I've done to it. Look at it. See? Nice. So we see that the package is tied up with string is added to the file, but we didn't delete anything from the previous iteration. If we go again, we can add in dividing by 0, courage, that kind of thing, and quit again. And so you see now here, these things are there in the file. So append mode is an interesting mode. The other thing to say about append mode is that there's a different read pointer and a write pointer. So I don't think Python syncs them up. Of course, now that every time I say one of these things, I'm always afraid that I'm going to say something stupid. But let's read line and print it out at the very end, right? So we've already written a bunch of lines to the file. So yes, project 2 is out. That's something to say. And then what else are we going to say? We're going to say who won't get fooled again. Great quote from a US president. And okay, then we quit. And so hopefully what we're going to see is that the 2 lines will write out here. And it might actually, I think it's going to print out this first what. Ooh, wonderful. IO unsupported operation not readable. We can fix that. There we go. This plus will ensure that the plus ensures that it's opened in read mode as well. That's right. So let's try this again. Let's just do ast and quit. Okay, so it didn't print anything out. So I guess it actually kept the file pointer along with the read pointer along with the write pointer. Sometimes the read pointer and the write pointer can get desynchronized, which is a slight problem. Anyway. So actually, I guess the read pointer basically it's just printing out the last end line. You notice that there's an extra end line here. Yeah, so adding the plus to a W will make it read and write. Adding a plus to an A makes it append and read. Adding a plus to an R means that it's read mode where you can overwrite things. if we move this out of the while loop, so the print statement is not actually in the while loop, it's just in the with statement. But I guess if we moved it in here, we'd probably see a different result. Argle bargle. To quote a great justice of the Supreme Court. Why didn't it print? Oh, there it did. Okay. What next? Nothing. Okay, so now it's just printing end lines. So here's the basic hint about reading and writing to the same file at the same time, is generally don't do that kind of thing. The reason why you don't want to read and write to the same... Ooh. Anyway, the reason why you don't... Hang on. Alright, had to yell at the dog. I think rolling my chair woke her up. The poor thing. Okay, anyway. So that's all I really want to say about files for now. I think I've said quite as much as I should say about files. Alright. No, dog does not like reading and writing at the same time. In fact, many things confuse the dog. The dog can generally only do one thing at a time. I've run experiments with her where I will present her with 2 toys and the poor thing does not understand. Okay. So, good. So now that I've talked about that, let's talk about what we want in terms of, let's see, to have it here. Yeah, so let's talk about testing. Is that animal testing FDA approved? So I think if that were scientific testing, you'd have to go through like the university ethics board or whatever. I remember, I don't know why I remember this so well, but every time I'd walk by it, I would see it in the physics building at UMD. They had this large warning sign that always said that you had to get permission if you were going to do any recombinant genetic work. And I was like, who in the physics department is doing that? So, anyway, that confused the crap out of me. So, okay, let's get back to testing. So, basically, this is kind of going to be a little bit of a review for the project, and it's going to be a little bit of review for the exam as well. So for the exam, my idea is that we're going to have like 3 coding problems that, as I said, they're going to be the difficulty of those problems. Hopefully lab is less than or equal to, like, difficulty of lab is less than or equal to difficulty of test is less than or equal to difficulty, well, maybe strictly less than difficulty of homework. This is my thinking. And yeah, I was saying lab plus. And then the other thing that we're going to do is I'm probably going to give you 2 debugging problems. And so your question should be like, what the heck am I going to do now? Because if I gave you a debugging problem, you could pretty quickly just kind of throw it into PyCharm and fix it up and not have to know almost anything. And so that's a good point. You have argued correctly. As it turns out, what I'm going to do instead is, let's just look at for instance, let's look at this buggy function. So I'm basically going to give you a prompt that's going to say something like, well, it'll say something like, find the 3 greatest numbers in the list and return them. right? And so you're going to ask yourself, like, okay, if I'm given this piece of code here, how do I fix it so that that happens, right? So it's going to be like a, this is what I want. I want you to find the 3 greatest numbers in the list, I guess my list, right? And return them in a separate list. Well, you might not think that this is the most complicated example, and it's not. But it's just an example that I came up with before class, so we're going to use it. So, okay. Oh my lord. Oh, that's not bad. I think that's fine. Good. So, okay. So basically here, and this goes into testing as well. So let's do 2 things at the same time. So you might also be wondering, what the heck is this testing script gonna have to be? So a testing script in Python is usually, it's its own function that is named after the function that you want to test. So find 3 max, and it has test in front of it. Okay, so and then what we want to do is we want to do something like this, where we say, let's say we want to test, so we say find 3 max buggy, and we'll say, let's give it 1, 2, and 3. And what we want is, let's say the result is equal to this. And so what you'll do is you'll say, well, I don't really care what order they come out in. I just want the 3 greatest numbers. It doesn't say that they have to be sorted or anything. So are there going to be errors in the coding standards? Coding standards are not going to be considered errors. So if it's just coding standard, then not an error. If it's some kind of coding standard that actually generates an error, then that's on the boundary. But again, it's either going to be a syntax error. Like, everything is either going to be a syntax error or a logic error, which means that either it's going to just not work, right? Either a syntax error is just something that breaks Python, or it'll be a logic error where, like, the code doesn't work, right? It doesn't perform the way it should. There's not going to be any coding standard violations. And I think that here there's no coding standard violations, right? Duplicate code. It just doesn't like that there's like a duplicate piece of code somewhere else in the project. It's just like, hey, wait, you've already implemented this function. Okay. So, and then we can say, like, if result, or if 1 in result, and 2 in result, 3 in result, we can print out test passed. Else, we can print out. So the debugging problems are going to be designed in a way that we could put the code in PyCharm. The answer is because everything in the universe now is a take-home. I don't assert, and I will not expect, that you don't use the resources, at least PyCharm and like maybe Python interpreter. You are not forbidden from using the resources that you have. I think it's a little stupid to ask you guys to like print out the exam, to write the code on paper, and then to like scan it in, right? If you're doing this remotely and you have to get the exam through a computer, then you're already on a computer. You can use PyCharm. So that's why I'm not going to focus on as many syntactic errors. Obviously, because if I just put syntax errors in, then PyCharm's going to find them for you and tell you what to do. So there's going to be a little bit more logic errors and a little bit less syntax errors. But this is just an example that I came up with this morning. So let's just go through this and see what we can make of it. So here, else test failed, output was. And so this is basically a single test. We'll call this one test. And so what is a test in the universe, right? In Python and anything. So one test is going to basically be this. It's going to be something where we give some input to our test, our function we want to test, and then we run the function, and then we check the return, or maybe the output in whatever way, right? So if it modifies a list, you check the list. If it will still be more errors than we need to find, so like fivers. So I'm going to ask this time for the debugging section that what you do is, I'll just show you when we get to it. So, okay, so let me just stick with this being a test. So this is one test, so we're going to run it. So we're going to say test find 3 max. So let's do that. And okay, good. We're on this function, or on this file. So let's run testing practice. Okay, so we got an error. The error is that what is returned? It says type error of type none type is not iterable. So that means if we look at the function, we see that it's printing out 3 most. It's not returning it. So this is exactly what I want you to do. I want you to comment out the line, and then I want you to say return 3 most. And then I want you to say something like line prints instead of returns. So basically do a little explanation. You don't have to, obviously if you then put a return statement here, you know, this is probably, don't have to explain this, already done above, right? So that's fine. You don't have to explain every single thing that you're doing, but this is one of the things that you can do on the exam, is just kind of, you would comment out this line of code, you'd replace it with this line of code, and then you see what happens. So, okay. So let's do this. All right, so this first test is passed. But does that mean that this function works? Well, it means that it works on this particular result, right? It doesn't mean that it works in general. So we have to think of other test cases that we want to use to test this function. So for instance, what if I tested on, say, 1, 2, 3, 4, 5, 6. And so the point is, what we expect to get is 4, 5, and 6. So we're going to say result equals that. And so we're going to say, we're basically going to copy paste the test code. It's okay if your testing code is a little bit ugly and repetitive. I was reading a book on unit testing at one point, and they basically said, like, if the amount of code you write for the tests is longer than the amount of code that you write for the actual thing, then you're kind of doing it right. And in this case, we're writing a ton of code for this, but whatever. So, okay, let's see if this works. I actually don't know if it will. Okay. So, what happened, right? So, in this case, this test failed, and the output was 6, 6, 6, and 4. So let's go up and look at this function and see what happens. So here, if the length of the list is less than or equal to 3, then it's going to append to x. So let's give you another example of a test that's actually going to fail in the same way. If I have 4 elements, let's see. There we go. Ooh. Oh. There we go. Okay. So why did this test fail? This test failed, well, obviously because I didn't add it yet, and when I added it, it caused the test to fail. So this test failed because the length of the result was not 3. And so the length of the result is 4 here, and the reason why is because if the length is less than or equal to 3, it appends. So you have to think about how many times that's going to happen. So what happens is it says, well, if the list is empty, it appends once. If it has one element, it appends twice. If it has two elements, it appends again. And that's where it has 3 elements, right? So when the length was 2, and we do 3 most.append x, now it has 3. But then here, the next time we check, when there's 4 elements in the list, well, the length is 3 now, and then it'll throw the 4th element in the list. And so that's not what we want. So you see that the difference is really this this equal sign. So what I would do is you delete the equal sign, and then you write a little comment here, which says changed less than or equal to just less than, because it will include 4. Right, so that's what I expect you to do when you fix this kind of problem. All right, so let's rerun the code. There we go. So now you see test passed and test passed. So now you have 2 tests that are passed and 1 test that is still failing. What test is failing? So the answer is, I mean, technically you can even just do, test 1 passed, test 2 passed, test 3, etc. If you write a lot of tests like this. There are packages in Python. One of them is called unit test that does a lot of this for you. Well, I shouldn't say that. It does some of this. It does about half of this work for you. The rest of it you still have to do. The real issue is that I don't want to teach unit test right now, so we're just going to, and because it's actually not that much more or less work to do it this way, we're just going to pretend like this is essentially our own little unit test module. So, okay, the point here is that really what we want is 4, 5, and 6, and what we're getting is 6, 6, and 6. So we're only getting 3 things now, but we're not getting the right things. And so the question is why? And so we look at the code again, right? And so we say to ourselves, okay, yeah, so I mean, basically, the description of the function will answer those questions. So basically, like, the description of the function will say something like, this function, or I should say my list, is a parameter, which is a list. This function will return the 3 greatest elements from a list, or however many elements if it's less than or equal to 3. So basically, I mean, I'll probably even provide more explanation than this, given that the thing is going to be like kind of more of an exam than anything, so I won't have you guys. I don't want there to be too many questions about the meaning of what the function intends, because otherwise then you'll sit there questioning like, oh, should the function do this? My goal is, you should know what the function will do and what the function won't do. So okay, let's check out this piece of code now. For I in range 3, so basically what this does is it cycles through the list if there's greater than or equal to 3 things. And so if 3 most is less than, at I is less than x, then we replace it with x. But you see the problem here is that when we have 4, 5, and 6, actually I guess what we really have is some, let's say that we have 1, 2, and 3, and we're about to put 4 in. So x is equal to 4. So what ends up happening is that it'll go through the list and it'll say, oh, 4 is bigger than 1, so replace it. But then it doesn't stop. It just says, oh, 4 is bigger than 2, so replaces it. Oh, 4 is bigger than 3, so replaces it, right? And so, there's like there's like 2 or 3 different ways to prevent this. I guess one way that I didn't think of when I was writing this up is you could always just do it something like this. You could say, while... Well, I guess it's equally the same. I was going to do it a different way, but it kind of is equivalent. So what I did to fix this was I added in a little flag variable here. So I basically said like appended or overwritten is equal to false. And then as soon as we overwrite something, we say overwritten to true. And here we'll just say, and, not overwritten. So the reason why I changed this to not overwritten is, okay, here we'll say we set overwritten to false. We haven't gone through the list yet. Here I'm going to say only overwrite one element with the new element, not all three. And here what I'm going to say is if you've already written the new element, stop. And so this is what I have in mind in terms of the debugging section on the exam. Basically, I want you to fix the code so that it works. And I want you to write comments about how you fixed the code. So, though I usually say, and I think it's generally true, that reading comments is terrible and you should never do it. In this case, I'm going to read comments. I'm actually going to tell the TAs, read the comments and believe them. So whatever you write in there is going to be, we're going to read it as your intention. So, unlike most comments and most code that may or may not be correct, we're going to assume that your comments mean something. And yeah, so you can always write little examples of like what tests failed and stuff like that. So this is kind of what I expect for the debugging section. And then what you'll do is you'll put this into a file and you'll submit this on the GL server for grading. Okay, and so you don't have to do this part. This is, yeah, so the exam is going to be submitted like a homework. So this part is not for the exam, but is for the project. So basically the point is that like this testing function is exactly what I want. I want things that look like this when we're doing testing, which is the testing script you're going to submit at the end, well, I guess next Monday. Well, so here's the thing. If I tell you, and that's a good question. That's a good question. So do we submit the test function with the fixed code? So not for the exam, because this is kind of mixing two things. So this is definitely like the debugging on the exam. This is what I want on the exam. This is what I want for the project. I want a bunch of functions that test your thing. Now, here's the thing. Someone asked, and it's a decent question, it's a perfect question. Well, we wouldn't have coded our project yet, so how do we know what tests we're going to run on what functions, right? Because I haven't written this function yet. I don't know what it's going to return. How can I design a test for it? Well, basically, here's the answer to that question. The answer to that question is if you take off the word buggy on this function, and I just say, okay, this function, I just tell you what this function is going to do. I say it's going to find the 3 maximum elements and return them in a list, right? And maybe even what we can do is just return sorted. That way it would simplify the thing. So we can say that instead of this, we can just say if 1, 2, 3, something like that. Oh, it still failed. Look at that. So why did this fail? Let's see here. I mean, yeah, it's supposed to, I mean, it's, the hope is that it's going to be about a 2-day assignment. I mean, my hope is that it's really like a 2-hour assignment at most, really. That's my hope, is that it doesn't take you any longer than 2 hours. Oh, this needs to replace the minimum. So yeah, we got to find the minimum. Well, so as it turns out, the test 3 still failed. So what we're doing here is we're saying, how long will you have for the multiple choice? Well, I don't know that I'm going to put a time limit on it. Especially anything that has code in it. I want to give you a few minutes to copy paste stuff. So, I mean, I expect the multiple choice won't take you more than an hour. Because it's only, I mean, I'm hoping that it's only going to be like 8 questions. So hopefully most of those questions can be answered in like 2 or 3 minutes. So maybe a half hour. I mean, I don't know that I'm going to set a time limit. Maybe I should set a time limit just so that no one takes 3 or 4 hours doing it. That's definitely... Now that I say, now that I said that, I instantly know. Well, I guess you can just call it 3 most 0 then. I guess I actually want it to be min index. And then at the end, what we'll do is we'll say if x is bigger than then we can replace the minimum. There we go. Is there an announcement? Well, I've talked about the structure of the test multiple times, and also I've released a practice test of the multiple choice, and I'm going over the structure of the debugging right now. So, I mean, I think that's a pretty clear assessment of how the test is going. No, so you don't have to... Basically, I'm just going to make it an assignment on Blackboard that you can start whenever you want. So you can start the exam at noon or 1 o'clock on Wednesday, or you can start it at 6 o'clock on Wednesday, or you can start it Thursday or start it Friday, I guess. Maybe I'll give you 2 or 3 days to do it, including the debugging and the other things. So just make sure you get all of it done, because it's going to be a little disjointed. Okay, so this fixes all of it. I guess what you have to do here is just kind of comment all this stuff, right? You would say like need to replace the min index. If you don't, then it could replace the middle element or even the max and cause strangeness. Yep, so this is finding the min index, and then if the min index, or I should say the element at the min index is too small, replace it. So basically this is what I'm looking for. Okay, let's do another example of this. Which one am I going to pick? I'm going to pick this one. So here's my isPrime function. So let's comment out the testing of this, and let's create a new function called test isPrime. And so what we're going to do is we're going to say, so this function just returns true or false. So the good thing is that what we're going to, let's just say we want to know isPrime. So as it turns out, 1 is not prime. So if false, then we'll print out test passed. Else, we'll print out test1 failed. 1 is not prime. And so that's a good example. So let's do some other examples. So some other examples of things to test. In fact, what we can do is copy paste. So now let's deal with test 2. Let's check to see that 2 is prime, right? Because 2 is actually considered to be prime. What else? Let's check 9. So test 3 is going to be checking 9. 9 is not prime. And good. 17, we'll check 17. So 17 is pretty prime. It's the best. It's a good prime example. Oh right, and so we always want this to be the right answer, so that is false. 16,127. I don't know, is that prime? Is it? Let's check. Okay, so okay. I know, right? I know. So, okay, let's run all these tests. Ooh, wonderful. So the first thing that we get is a division by 0 error. So that's even worse than a normal bug, right? So we're going to go up here and we're going to look and see what happened. Right? So when you look at this code, checking to see if n is between -1 and 1, that's not a problem. If it is, then we return false. This stuff is okay. A-okay, no problem. Yeah, so the problem here is the range, because you see that here the variable is k in the loop. And even if you don't know anything about prime numbers, even if you don't know anything about anything, what you do see is that you have a k in range n, and you know that there's a secret 0 here. Because there's a secret 0, the first thing that's going to happen is we're going to do n mod 0. And so you can't do that. Now, let's say we change this to 1 and see what happens. Okay, cool. So it says test 2 failed. 2 is prime. So it should. So this should come out as true, but it's actually coming out as false. So why is that coming out as false? So it's not getting caught up in here. But here, what is n mod or 2 mod 1? 2 mod 1 is 2 mod 1 is 0. So since 2 mod 1 is 0, it will not return. And then because of that, it's going to return false. So the actual hint here is 0 was bad, but we don't want to mod by 1 either. Because whenever you divide an integer by 1, the answer is going to be that integer with a remainder of 0. So actually the answer is always, the answer to this is going to be always 0 if you use k is equal to 1. So let's do that. Okay. And so actually what's happening here is that we want this to be 0, not non-zero. So let's see what happens if we fix that. Ooh, beautiful. Breaks everything. What's happening here in test 3? So 9 is not prime. Everything is flipped. I forgot what I did to screw this function up. Now I'm remembering. So, yeah, so if it is divisible, you want to return false. This means it never got divided by anything less than it. Right, because we don't check 1 and we don't check itself. So there we go. Okay, now all the tests have passed, but I still don't trust this function. So let's try it on something like 125, which is let's call it test 4.1. 125 is not prime because it's 5 cubed. Okay, that's working. So if it works on basically all these numbers, are you guaranteed that this function works? This is one thing that the testing community, the people who swear up and down by tests, don't understand about things in the universe, is that there is no set of tests that will ever completely describe every set of user input or every set of conditions that can possibly happen. It's just not going to. You can trace down every logic path, but you can't trace down every logic path of every single event, like the difference between 7, for instance, and 9 and 11, and then etc. So do you need to test the tests? The answer is, to some extent, yeah. You know, you'll never 100% know if a test is the problem or your code is the problem. Now, in this case, this one here, you know, if I was fed lies by some rando on the internet, then the answer is that I wouldn't even know if this number were prime. I guess it is prime because I think this function does work now. So, oh yes, Gödel, this is basic. I mean, sadly, in the end, you can definitely talk about the incompleteness theorems here that say that, like, there is no way from within a system to prove that system's consistency as long as that system is strong enough to contain arithmetic. And so, as a philosophical matter, there's just no set of tests that will ever 100% prove that a function works. Unless, of course, that function is literally a single if statement with two conditions. If x equals 1, return true. If x equals 0, return false. That's pretty easy to do. Anyway, so, but as I say, there's no single finite set of tests that will ever 100% demonstrate your function works. So what should your goal be when you're generating tests? Your goal needs to be to generate tests that span the as many possibilities as you can think of. And so that's what you essentially want. You want to, is it 1S? Why is it misspelled? I don't know. Anyway, so you want to think about as many possible tests that span as many possibilities as you can generate. And the point about the tests is that you should know the answer. Don't make the problem so hard that you don't know the answer to the test. Because that's one way to write a test where you think that your function is broken or you think that your function works, but actually you are not correct, because what happened was you wrote a test that described a condition that you didn't completely understand. And so every test, so in the unit testing philosophy, the test should be, tests should be as simple as possible to test a single functional aspect or logical path. So for instance here, 1 is testing this if statement here, and nothing else is testing this. So we should have at least one test that speaks to this little exception bit of code, right? If we don't have anything here, then yeah, we're just in trouble. Testing 2 is important because you see 2 is a weird case. 2 happens to be the only even prime, but the other thing about 2 is that if you look at the way that this function is written, the range of 2 to 2, this thing is going to be null, right? Or I shouldn't say null. It's going to be, it's just not going to iterate. So because this doesn't iterate, we immediately drop through without checking anything. When you when you have 2, this statement is false. It drops through this for loop without checking anything and just returns true. So in that case, 2 has to be prime. And actually it is, so that's good. If it wasn't, then we might have to check like an additional, if n is equal to 2 here, right? But the point is that we don't have to do that because, as it turns out, 2 is actually prime, so we're okay with this return value. And so that's why 2 is an important case. 9 is an important case because it's called the engineer's prime, right? Being the engineer's prime means that, if 2 is prime and 3 is prime and 5 is prime and 7 is prime, then you're like, oh, well, I see a pattern. It's just the odd number, so 9 has to be prime. But of course, 9 is 3 times 3, so it's not. So, it's a little joke. I think I made the joke in class before. But the point is that you want to check it, right? Because just in case, it's a mathematical possibility. And then here's a prime, right, that's not 2. So it will go through a range of things to check in their code, right? So this will definitely, engineers definitely have an interesting philosophy on the world. So if the prime buggy on 17 comes back true, then we know that at least this for loop did some work. And it never returned false, which is correct, right? The other thing you might want to do, so here this prime number is true. So actually, this is a like extreme test. The thing is, it's not even like it's a decent test. But if we had to add one more test, one more thing I would test is probably some composite number that's not 9, right? Something that's not a prime to a power. So let's take 48, for instance, right? This is not a prime to a power, just some rando number that is definitely not prime, right? So if the thing returns false, then that's correct, because 48 is not prime, right? 48 is equal to 12 times 4, which is equal to 4 times 3, yes, which is equal to 2 to the 4th times 3. So this thing is not really anything, right? This is just, it's this number times that, it's just some prime factorization that is not any particular thing. And that's actually a good thing, because the thing is, we were testing all these special numbers, 1, 2, 9, which is 9 is a special number, right? Because it's a perfect square, it has all kinds of properties. Maybe our for loop doesn't works right on perfect squares, but it doesn't work right on just random. Like here, it's a perfect cube. So, just because perfect squares and perfect cubes are beautiful doesn't always mean that they're the best tests. 48's a good test here because it just says, like, hey, I'm testing something that's definitely not a prime. It's not a prime to a power. It's not a prime to this thing. It's just a bunch of random numbers multiplied together. So, and you run it, and everything passes. So at this point, after those tests run, you should be fairly certain that this thing probably works in most of the cases. Now, of course, you might say, well, it's always possible that you can come up with some case that is going to break this, but it's one of those things where you just have to kind of, at some point, you have to be like, well, I believe I've come up with all the possible test cases for all the possible situations. I've traced through the logic. I think it works, and all the tests are passing. And at that point, now, if you were a true tester, if you believed in the testing methodology, you would at that point say, therefore the code is 100% perfect and works and no problem. The mathematician in me prevents me from saying that. I can't really say that. I have to say something a little less strong. I have to say something like, the tests complete successfully and span most of the cases that we can think of, so the code probably works, right? I think that's really, in some sense, as much as you can ever guarantee, unfortunately, with code, is that it probably works. But I mean, that's not what you say in a job interview. You say, there is a high probability that my code works. That's not what you say. You say, my code definitely works. I write unit tests. People don't like to hear about the uncertainties. Will there be a submit command for the exam? Yes, there will be a submit command for the exam. It'll be just like the other GL submit stuff. All right. I think I've basically gone over everything that I needed to go over. I was going to talk about default parameters a little bit, but let's not. So on the day of the exam, there will not be, Ben and I brought it up to Ben just this morning, and I reminded him that now that we're giving the exam in kind of a remote fashion, we could technically have class on Wednesday, and he was shocked and horrified by this fact. So he decided that we're gonna cancel class. So yeah, we'll end class here, and we will not have class on Wednesday. I'll send out an announcement about that so that there's not a lot of confusion. All right. Have a good rest of your day, people. I'll upload this stuff to the GitHub, and yeah, you can kind of look over it and kind of figure it out, because I think this is going to be a pretty good example of debugging problems, and also at the same time a good example of testing. All right, if that's it, we'll seal the ports. When will dog happen? I need to, maybe I'll do I could do a dog stream from my living room. Maybe on Wednesday when I release the exam. Instead of having class, I'll just stream me playing with my dog for 10 minutes. We'll see how many views it gets. If it gets more views than a lecture, then I'll be sad. It probably will, because dogs are much more favored than Python, I think. All right. Signing off.